Hi everyone, this session is we're going to go through mechanics and hopefully when you understand this, hopefully more difficult ones will make more sense. So I'm going to go through three cases that generally come up. Object on a horizontal surface and one hanging off the end. And again, these ones are examples of smooth surfaces that objects are sitting on, as well as the string being inextensible, so it doesn't extend like a rubber band, which will cause tension to vary across it. So that's why you'll have an inextensible string. Okay, so the first one, as I said, is on a horizontal surface, one hanging off the edge. Second one is two masses hanging on either sides, almost acting as in opposite directions. And the third case is when you've got a slope. You've got one object on the slope and the other hanging off the end. Okay, so we're going to tackle each one of them at a time with the explanation where the forces apply, and we're going to put some example masses on them. So first example with the horizontal surface and one hanging off the edge. So what we'll do is we'll put a weight on each, so 10 for the one that's acting down and 5 on the horizontal surface. This is to kind of show there's a, but basically one hanging off the edge is going to go down, it's going to accelerate down, so the net force will be going downwards. So on the strings, there's a an opposite tension force. You've got to put in there as T. And there is no friction on the surface, so therefore no resistance or no resistance force. So nothing acting in the opposite direction to the movement of that 5 kg object. Okay, so we're going to go to look at A. Now there's a vertical forces R1 going off the plane, basically what it's sitting on, and a gravitational force of 5g. They just cancel each other out, so ignore that. Now we're looking at the horizontal forces. There's only one, that's tension, the string that's pulling at that 5g mass. So it's T equals 5, which is the mass of the object, A. So T equals 5A. Now we're going to look at B. So this one, you've got 10 kg mass, so B, F equals ma. So what are the forces? Well, it's going down, so it's 10g minus t. So the t is the pulling it up in an upwards direction, and that equals the mass of the object, 10 times a, 10a. Now what we can do is substitute t with 5a, okay, in equation B, and then you will have 10g minus 5a, okay, and that equals 10a. So let's write that down. 10g minus 5a equals 10a. Okay, now we'll just rearrange the equation. So you've got 10g equals 15a, and then a equals, not that, it equals 10g over 15. Let me just correct that. 10g over 15, okay, which is a third or 2/3 g. Okay, all right, so that's example 1. Example 2 is two objects hanging off a pulley. Okay, now here you've got, again we're going to use 5 and 10. You've got the gravitational forces on them, and you've got the tension. So looking at the first part, you've got a gravitational force of 5g and a tension upwards of t. Second part, gravitational force of 10g, a tension of t upwards. And look at A again. A, so here, because we're assuming that it's going to be moving clockwise, so the 5g is going to move upwards. So the net force is going to be T minus 5g. And that equals 5a, 5 being the mass of that object we're looking at. B, now we're going to look at that. I'm going to say, now it's going to go downwards, so it's 10g minus t is the net force, and that equals 10a. Now, what we want to do is to work out acceleration, we can get rid of the t's by adding a and b together, and you end up with 5g equals 15a. Okay, so we write that down, 5g equals 15a. Then a equals 5g over 15, which is a third g. Okay, right, so that's the second one. The third scenario we're going to look at is we're going to look at a slope. So this is where you've got to use a bit of trigonometry because the gravitational force is kind of split up between that acting along the plane and into the plane. So you need to be able to look at that. So again, using the same masses, and we'll use an angle of 30. That's always the one they use, nice and simple for calculation purposes. So as I said, 5gx downwards because of gravity, but we need to split it up because the tension is acting along the plane upwards because it's being pulled up, the 5g, and the 10g is pulled down. So how do we work out the opposing force, i.e. the force of that 5g along the plane? Well, you've got to draw a right angled triangle, so that net force of 5g is split into two forces, one which is along the plane and one is into the plane. Okay, now you've got to work out what angle, where that 30 degrees goes in that triangle. So you know one of the angles is a right angle, another angle is 90 minus 30 because that's part of that triangle with the 30 degrees. Therefore, the one on the bottom is 30 degrees. Okay, so now you can write the formula. So you've got basically down the plane, you've got a force of 5g, and it would be sine 30. Okay, 5g being the hypotenuse of that triangle, and it's going to be opposite the angle, so it would be 5g sine 30 is acting down the plane. So let me just correct that. It should be 5g. Okay. Now we have that, we can now write the equation. So as the object is moving up the plane, it would be t minus 5g sine 30. Okay, that's the force, the net force. Again, net force is important. No other force because it's a smooth plane, and that equals 5a. Okay, b, right, force on this is 10g acting down, and there's a tension force acting up. So in this case, because it's moving downwards, it's going to be, the net force is 10g minus t, and that equals 10a, 10 being the mass for that part of the system. Okay, now we can add a and b together to get rid of t, and then you can work out acceleration. Okay, and that will give you 10g minus 5g sine 30 equals 15a. Okay, now sine 30 is a half, as you probably know, so that will leave you with 7.5g equals 15a. So I'll just write that out. 10g minus 2.5g equals 15a. 7.5g over 15, 7 over 15 is the answer for acceleration. Okay, now you've got that, you can, if you want to work out tension, you can work it out because you know what the acceleration is, so it's pretty straightforward. And I think that's it, hopefully that's understood, and any comments, please leave them.